Hi and welcome back to My Physics Teacher by Mr. Cannon. This series of laser sharp revision videos reviews the energy topic. A link to the blank revision sheet is in the description below to allow you to make notes as we go and revise from. By the end of this video, we will have reviewed gravitational potential energy, so mass times gravitational field strength times height, kinetic energy, a half times mass times velocity squared, and how they're interlinked when we look at some energy transfer examples. Remember, stick around to the end so that we can go through some example flashcards to help focus your revision even further. So did you know that the gravitational field strength on Earth is 9.8 newtons per kilogram? But in your exams, you will always be given that number. It's not something that you need to remember. This number is sometimes rounded to the value of 10 just to make calculations slightly easier, but always use what the examiner wants you to use. The definition for kinetic energy is that an object that moves, so all moving objects, they will have a kinetic energy store. For gravitational potential energy, an object lifted above the ground has a gravitational potential energy store. So if you lift it higher, it will have a larger gravitational potential energy store. We're now going to focus on this ball moving from the top of a hill down to the bottom of the hill. But first, let's just remind ourselves of the equation for gravitational potential energy. It's mass, so how much mass the ball has in kilograms, multiplied by the gravitational field strength, so on Earth that's 9.8, multiplied by how high it is above from the ground. And of course, gravitational potential energy is energy, so it's measured in joules. In this example, let's say the mass of the ball is 2 kilograms, and that from the ground it's 10 meters up. I always advise to write the full equation out or to write it in shorthand, so we know GPE, gravitational potential energy, is mass times gravitational field strength times height. And it's really good practice to show the examiner that you know and recognize what each value links to. We're trying to find GPE, so we leave that as GPE. Under M, we write 2. Under G, we write 9.8. And under H, we write 10. In science, we can always use a calculator, so put those numbers in, and it gives us a gravitational potential energy of 196 joules, with a capital J. However, this ball is going to roll down the hill, and as it does so, the gravitational potential energy store will decrease. It's getting lower. But that energy, remember, does not disappear. It gets transferred into another form. As it falls, it speeds up. So in other words, our gravitational potential energy gets transferred into kinetic energy. A trick that's often used in physics is that we can put these two equations equal to each other. Gravitational potential energy at the top equals the kinetic energy at the bottom. So as a reminder, the kinetic energy equation is a half. I prefer putting 0.5 into the calculator, times by mass, times by velocity, squared. Let's look at an example. Just like before, we'll write out the equation. I've done it here in shorthand. This is where people don't realise, but we can say because it's got 196 joules at the top, it must have 196 joules at the bottom. If all of the energy gets transferred from gravitational to kinetic, the amount of energy that the ball has must also be what it started with, 196 joules. We can then use this equation to find the value of the velocity at the bottom of the hill. We can substitute in the other unknowns. The half stays as 0.5. The mass of the ball hasn't changed, but we're trying to find v. But we need to remember it stays as v squared, velocity squared. Before rearranging, I prefer to simplify what's on the right-hand side if I can. So 0.5 times 2 becomes 1. So I've still got 196 equals 1 times v squared. So to simplify, 196 equals v squared. And the final step is to get v by itself, so we have to square root both sides. So the square root of 196 works out to be 14 meters per second. Now it's time to make some flashcards. So some ideas that you might want to use. On one side have kinetic energy, and the other side we can have our definition. So kinetic energy, all moving objects have a kinetic energy store. And of course, it's useful to know what the equation is. Similarly, for gravitational potential energy, an object lifted above the ground has a gravitational potential energy store, And again, we have our equation. As a reminder, the value of gravitational field strength will be given to you in the exam, but typically on Earth, 9.8 is the number to look out for. Thank you for watching, and if you enjoyed this video, please remember to like, share, and subscribe. See you next time.